Now, before I show you how to solve a system of equation with matrices, we are going to just solve it using the old algebra 2 way. So let's look at the system of three equations and let's try to solve it. So in order to figure out what x, y, and z are, because that is three variables, we need three independent equations, which we do have right here. And what we want to do is we want to solve for one variable at a time. So if the system has three variables and three equations at one time, it's impossible to solve. So what we need to do is reduce it to just two variables first, and then we're going to reduce it to one variable, therefore solving that variable, and then plugging it back to figure out the answer. Anyways, all right. So if you look at the system of equation, you kind of think to yourself, which variable should I eliminate first so that I can solve for the other two variables? And it looks like it's very easy to see that it's better to eliminate z because you can see that there's all the z's have a coefficient of 1, and then there's just a plus and minus sign in front of it, so it's easier to eliminate. So what I'm going to do first is I'm going to number these equations so it's easier for us to talk about them. So what I'm going to do is eliminate z, and to do that, what I'm going to do is add two equations together to get rid of z. So using the elimination method. So I'm going to add 1 and 3 together because I can see that z's on those two in those two equations are opposite signs. So if I add them, I would be able to eliminate them. So, all right, this is equation 3. All right, adding them together, 3x minus 4y equals 10. And then I'm going to pick 2 and 3. So 3x minus 5y plus z equals 14. 2x minus 2y minus z equals 3. Add them together, 5x minus 7y equals 17. All right, so I've reduced three equations, three variables down to two equations, two variable. And you might say, where are the two equations? Well, the two that I just reduced to. All right, that's pretty good. So now what I'm going to do is I'm going to reduce it even further, basically just solving system of equation with only two variables. And so looking at it, you ask yourself, which variable do you want to eliminate? I'm going to eliminate x. And in order to do that, the coefficients need to be the same but opposite signs. So what I'm going to do is make them both 15, but one of them positive 15, the other one negative 15. All right, so 15x minus 20y equals 50, minus 15x plus 21y equals negative 51. All right, add straight down, the x's cancel, so y equals minus 1. All right, that's good. And now what we're going to want to do is go back and solve for the other variables. So since we have y equals to something, we can either use this one or this one to figure out what x is. So it doesn't really matter which one. I'm going to use the left-hand one. So 3x minus 4 times negative 1 equals 10. So 3x plus 4 equals 10. 3x is 6, x is 2. And the last thing I'm going to do is go back to the very beginning and then pick any one of those equations, any one of those three, and then solve for z. I'm going to pick the first one because the coefficients look smaller. So x is 2 minus 2 times y is negative 1 plus z equals 7. All right, so 2 plus 2 plus z equals 7. So 4 plus z equals 7. Z is 3. All right, when you finally finish solving the equations, what you want to do is write it in the coordinate system, x, y, z. So this is equal to 2, -1, 3. All right, so this is the system of equation or how to solve system of equation using algebra way. What we're going to do now is we're going to write it in the matrix way, and then we're going to use the calculator to help us solve this. Well, there are two methods. One is called this reduced row echelon form, or RREF for short. And then I say RREF because it's going to show up as RREF on your calculator. And to actually get it into the reduced row echelon form, we need to first rewrite the system of equation as a matrix. Okay, sorry. So what we're going to do is, this is the same example as the previous one. We're going to first rewrite this system of equation as a matrix. So very easy. What you're going to do is take the coefficient of every variable and then put that into the matrix. Because in the matrix, as you have already known, that it's only numbers and there are no variables. So for example, in this big matrix, you're going to put the coefficients for x in this first column, y in the second column, z in the third column, and then after that is the constant. And then make sure it's always in order. So in the first equation, x minus 2y plus z equals 7, we are only taking the constant or the variable, the coefficients. So that's going to be 1, -2, 1, 7. 1, -2, 1, 7. So I put a line there because that kind of reminds me that is the equal sign. Okay, I'm going to do the same for the second equation. So only taking the coefficients. 3 minus 5, 1, 14. 3 minus 5, 1, 14. And then the last one, 2, -2, -1, 3. We're going to learn how to reduce this by, or how to get the answer by hand. And then I'm also going to show you how to do it by calculator. Okay, so the idea is we want the reduced row echelon form to look like the identity matrix. Identity matrix, if you remember, was 1 down the diagonal from the top left to the bottom right, and then everything else is just a 0. And the reason being, if everything else is a 0 and then you get numbers here, then this, if we reconstruct this equation, we would just get, remember, this is the x column, this is y column, z column, and this is the constant. And this line here represents the equal sign. So if I were to reconstruct this, I would just say this is 1x, right? Because 1 is the coefficient for that column x, equals a. And this one means y equals b. And then this last one means z, or 1z equals c. So if we can get it into this form, we basically solve the matrix. So we're going to use the calculator to do this for us. So let's take out your calculator and practice putting this in your calculator. So to enter a matrix in the calculator, what you're going to do is press the second button. And then you're going to press the x to the -1 button. That is on the left-hand side, 4 buttons down from the top. Because on top of that, it says matrix. So you want to go into the matrix function. And then you're going to see a screen that looks something like this: names, math, edit. And when you first enter the screen, you're on names, and then it has 1, and then A, 2, B, and so on. So what it's saying is, these are all the matrices that are available, and you can do whatever you want with it. What we're going to do is first create a matrix. So we're going to created by actually just editing. So you're going to go to edit, and then when you go to edit, the same matrices appear again. So if you never touched it before, there's nothing in any of the matrices. So you're going to go to edit and then just pick A. Once you pick A, it's going to ask you what size is, so this is one screen. So after you pick A, it's going to ask you what is the size of your matrix A. And then so what you're going to do is you're going to tell it what size, row by column. So in our matrix here is 3 rows by 4 columns. So you're going to say it's 3 by 4. So you just press enter. So 3, enter, 4, enter. And then it's going to give you this really big matrix that is 3 by 4. And then there's going to be, I believe it's nothing to begin with. And then so you just start entering from A11. So 1, -2, 1, 7, and so on. So you go to the next element by just clicking enter, 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 and then it will just kind of go A11, A12, A13, and so on. So then you enter all the numbers in the matrix, just like so. And then what you're going to do is now you want to calculate the answer, so the RREF version. So first, you need to exit out of the screen. So this is a little bit confusing for a lot of people because they didn't realize that they actually had to exit out. To exit out to your calculation screen, you just click second mode because on top of mode it says quit. So basically go back to the original screen. Okay, now that you're in the calculation screen, what you're going to do is we're going to calculate the RREF. So you're again going to go to the matrix version. Okay, so you enter into the matrix screen. And then again, you're going to see names, math, edit. And when you're in here, what you're going to do is you're actually going to go to math. So when you go into this part, I don't remember what the options were, but one of them says RREF. It's very close to the bottom of the list. So you click on that one and then enter. And then in your main screen where you usually do calculation, it's going to say RREF. And then I believe there is a open parentheses. And then you're going to do this one more time. You go to second matrix, and this time you're going to go to names, because now you're going to choose the matrix that you want to do RREF on. So this time you go to names, and then you stored your matrix in matrix A, so you're going to leave your cursor on A and then press enter. And now it's going to say RREF matrix A. And then press enter again. And then it will give you the answers in matrix form. So it should look something like this. What was our answer before? 2, -1, 3. So you're going to see 1, 0, 0, 2, 0, 1, 0, -1, 0, 0, 1, 3. So that tells you that this is the answer to 1, -3. Okay, now I'm going to review really quickly how to solve this by hand. So first, what we want to do is create the matrix. So this is that same problem again, and we're just gonna solve it by hand this time. All right, so what we're gonna do is I'm gonna number these rows so it's easier to talk about them. So the whole idea is we're going to try to get to the reduced row echelon form, which is the identity matrix, by hand. And we had to follow a few rules about how to manipulate these rules. So whole idea is we want to get 1 and then 0, 0, 0, 1, 0, 0, 0, 1. And then if we get to that point, then this part is automatically the answer. All right, so just like last year, there is an order to this that I find helpful. So here's how I do it. I first get this to be 1, and then 0, 0. And then I go to this one, whatever that number ends up being, and I get that to be a 1, and then 0, 0. And then the last thing I do is I make this 1, and then 0, 0. And of course, you can't just arbitrarily make them a number that you want. There is a rule to this. All right, so let's start. So the first top left-hand corner is already a 1, so that's good. We need to get that 3 and a 2 below it to become 0. So how do I do that? Well, I'm going to add whatever I want to get that to be a 0. So for example, this 3 needs to be a 0. In order for this to be a 0, I cannot multiply this whole row by 0 because that will eliminate the whole row. So what I'm going to do is I'm going to use this row because this has already become a 1. So I'm going to use this 1 to help me kind of get rid of this 3. So to do that, what I'm going to do is multiply this by -3, which means multiply the entire row by -3. Okay, so I'm going to write that down. Okay, so multiply the entire row 1 by -3, and then I'm going to add to row 2. So if this had become a -3 and then I add to this row, then this spot becomes a 0, which is what I want. And then, so that means I'm going to take that result and then replace row 2. All right, so let's do that. So -3 times the first row, so every number in the first row, and then add to row 2. All right, so let's do some calculation here. So -3, 6, -3, -21. Row 2 is 3, -5, 1, 14. Add them together, 0, 1, -2, -7. And then I'm going to take that and replace row 2. So row 1 stays the same. Row 2 becomes 0, 1, -2, -7. Row 3 is the same. I'm going to renumber them so it's easier for me to talk about them. All right, this is good. So now what I'm going to do is the same thing, except this time I'm going to get rid of the 2 from the third row, and then I'm going to do that the same way. Multiply row 1 by -2, add to this row, and then replace this row. So I'm going to write that. -2 times row 1 plus row 3, and then replace row 3. Okay, so -2 times all the elements in row 1, add to row 3. So this is where you have to be very careful and not make a very simple calculation mistake, because then, you know, every place that you make a mistake, it's just impossible to get to the answer. All right, kind of running out of area here. I'm going to go up here. So row 1 is the same. I didn't change it. Row 2 is the same, 0, 1, -2, -7. Row 3 is 0, 2, -3, -11. All right. Okay, so the order was the first one, and then get the zeros, and then the 1 here in the second column, and then I'm going to make these 2 zeros. Okay, same logic. So in order to get this first one, oh, I'm sorry, this number to be a 0, I'm going to multiply this row by 2, add to that row, and then replace that row. Okay, so write that down. So multiply 2 to row 2, add to row 1, replace row 1. 2 times the second row, add to row 1. Okay, 0, 2, -4, -14, 1, -2, 1, 7. Add them together. 1, 0, -3, -13. Oh, I'm sorry, not -13. What am I doing? -7. Okay, replace row 1. 1, 0, -3, -7, and then everything else stays the same. All right, kind of almost done here. All right, so same thing. What I'm going to do is get rid of 2 using the same trick. So multiply the second row by -2, add to row 3, replace row 3. Running out of space again. Oof. Okay. 0, 0, 1, 3. Ooh, that's good. We solved our first number. All right, so let's see. First row, 1, 0, -3, -7, 0, 1, -2, -7, and then the last one is 0, 0, 1, 3. All right, go ahead and finish this problem using the same trick. The last one, you can see that this 1 is already there, so you just need to make these 2 zeros. So go ahead and try this. Now, since we have already solved this problem a few times, you know the answer, so you should get 2, -1, 3. All right, let's have you pause the video and then try this one. So you should try it by hand and with the calculator, and then come back and check your answer. All right, the answer is 2, -1, 4. So anything I ask you to solve by hand, you're going to get an integer so you don't get confused. So if you end up getting a fraction or something, you know you did something wrong. All right, the second method is to use the inverse matrix. If you kind of remember this from last year, inverse matrix, we're going to do them all by calculator. All right, so inverse matrix setup is a little bit different from the reduced row echelon form. So what we're going to do is we're going to make a few matrices. So we're going to have the coefficient matrix times the variable matrix, and then we have equals to the constant matrix. Okay, so what does that mean? First, you got to make sure all your variables are on the left. So they have to be in order. So x, y, and if you have more, z, and so on. So you put that on the left, and then you have an equal sign, and then you have the constant on the right. So you got to have that set up first. Next, you're going to take the coefficient again, just the coefficients. So this part is just 3, -2, and that goes into the coefficient matrix. And then let's just do the next one as well. So that's going to be -1, 1. In the variable matrix, you're going to go straight down. So x, y, if you have more, z, and then so on. And on the right, you just have 2 numbers for the constants. So what you're going to do now is you're going to try to solve for the variable matrix x, y. So if you can solve this, then you can get the answer. Now, how do you solve this? Well, you got to get rid of this, right? And to get rid of this, you cannot divide by a matrix, right? In the matrix world, there's no division. However, to get rid of a matrix, what we want to do is use the inverse matrix. Because remember, inverse matrix times the matrix itself gets you the identity matrix. So that's essentially kind of like a 1. So if we can get the inverse matrix to multiply, then we will basically essentially get rid of it, like dividing. But inverse matrix is very important, or actually multiplying matrix is very important that the order matters. So you see how I am multiplying the inverse matrix on the left of this matrix, Then order matters. I got to make sure this matrix is multiplied on the left of this constant matrix. So this is where a lot of people get confused. They just kind of randomly multiply, which is okay in the number world, but not so in the matrix world. So make sure order matters. All right, so that actually just means xy is equal to the inverse matrix times the constant matrix. So if we can solve that, we have the answer. Now, this one is easy to solve by hand, but I'm going to show you how to do this on the calculator. So in the calculator, this is a little bit tricky because now you need two matrices. You have this one, let's call it A, and then this one, let's call it B. So now what you want to do is go back to the calculator and then go to where you have the matrix, where you enter the matrix. Oops, matrix. And now you need two matrices. So you're going to create one for A, or you go to edit, and then this one is a 2 by 2 matrix. So once you change that to a 2 by 2, it will automatically reduce the size, and then you can change all the elements. And then you're going to go to edit again, and this time you're going to go to a second matrix, matrix B, which you're going to enter the 0, 5. That 0, 5 is a 2 by 1 matrix, so make sure you put a 2 by 1. And then just go back to the calculation screen. So remember, going back to calculation screen is second, and then mode, which goes back to quit. All right. Now, what you're going to do is you're going to ask the calculator to calculate this matrix with the inverse for you. So what you want to do is go to the matrix again. So go to the matrix, and then this time in the name part, you're going to select A. So A matrix. And then where you have that matrix button, remember that button was actually at x to the negative 1. So what you want to do is click on that, and then this will automatically give you this negative 1, which means inverse in this case. And then you're going to go back to the matrix to again select B. Okay, this tells the calculator to calculate A inverse times B. And when you do that, the answer is 10, 15. So that means x is 10, y is 15. All right. Oh, we only did a calculator. All right, so let's do a larger matrix. So this one, oops, sorry. So we're going to do the same thing, and this time we're going to practice with inverse matrix. So remember, you're going to have the coefficient matrix, the variable matrix, which in this case is x, y, and z, equals to, and then the constant matrix. And then remember, in order to get rid of, to find the xy matrix, x, y, z matrix, you need to multiply by the inverse matrix on the left, which means you need to multiply by the inverse matrix on the left of the constant matrix. And then again, in this case, you want to create two matrices, A and B. A being the coefficient matrix, and then B being the constant matrix. Okay, go ahead and pause the video and then just write the setup. And then if you can, go ahead and just calculate it. And then come back and check the answer. All right, so this is the setup. And then using the calculator to figure out the answer. And here is the answer. So if you use the calculator, you're probably going to get some kind of decimal instead of 118/3. You can write out the decimal, or you can kind of go backwards and think what rational number would that be. All right, let's try this one. This one's kind of weird. We have 4 variables and only 3 equations. So that tells us that it is unsolvable. But what we're going to do is we're going to solve it to the best of our abilities, and then learn how to write a solution that is infinitely many possibilities. So I'm going to do this one in reduced row echelon form. just so we can kind of remember how to practice that. Okay, so I'm gonna kind of so that we all do this the same way. So we're gonna put the W in the front. So this is W plus, and I'm gonna get rid of that. So when we write this whole setup, since there is no W here, that's really just a 0. So 0, 1, 2, -3, and I'm using reduced row echelon form, so I'm gonna have one big matrix. Okay, same thing here. 1, 2, 3, -4, -1, and then 1, 3, 5, -7, -2. All right, so enter that into your calculator. This is 3 rows by 5 columns, so 3 by 5. Okay, enter that, and then we are looking for RREF, and then let's see what the calculator gives us. All right, so looking at our calculator, this is the answer that's given on the calculator. 2, 1, 0, 1, 1, -1, 0, 1, -2, -1, and then we have 0, 0, 0, 0, 0. So that tells us this whole line being 0 or whole row being 0 just tells me that that equation doesn't exist, meaning there was one equation that is actually a redundant or a repeat of some other equation, and so it was not giving us extra information that allows us to solve the variable. So essentially, these 3 equations actually only reduces to 2 equations, 2 independent, meaning they're unique equations. Really only 2 equations trying to solve 4 unknowns. That is impossible. So what we're going to do is we're going to write the solution as to the best of our abilities, but we are going to write them as equations first. So that's 2w plus x plus z equals 1. And then the second equation is minus w plus y minus 2z equals -1. So, you can kind of do whatever you want, meaning this is an infinitely many solution case. So that means we're going to have to say, let's keep 2 variable that is constant, and then everything else is going to depend on those 2 variables, because we really can only solve for 2 variables in this case anyways. So I see that W and Z are repeating. So what I'm going to do is I'm going to say that W and Z are fixed. So I'm going to fix W to a number, I'm going to fix Z to a number, and then when I fix them, that kind of tells me that I can actually solve for an X and Y in relationship to those fixed numbers. So I'm going to fix W and Z. They're just going to be variables on their own with their own numbers. And then what I'm going to do is write X in terms of W and Z, because those are my fixed variables. So X in this case is, if I just kind of solve it, 1 minus W minus X. I'm going to do the same thing with Y. So Y is equal to W plus 2Z. So if I say that, we have this coordinate system that has 4 variables, W, X, Y, Z, then I can say that, okay, then if the variable is W and then I have a number for W, then X would be 1 minus W minus X. I'm sorry, not X, that should be a Z. And then Y should be W plus 2Z, and then Z is just itself. So this is where I fix 2 numbers and, give them some number, and then everything else is in terms of W and Z. It's a little bit confusing. I know we never really see anything like that, but we can write variables in terms of other variables. Let's say if this case did not happen and you get something like 0, 0, 0, 1, 0, I'm sorry, wrong case, 0, 0, 0, 0, 1, like this. So the variables are all gone, and then you have a number on the right. What does that mean? That means no solution. because all your variables are gone and then you have a number. That is impossible. So remember in the case in algebra 2, you have something like 2 equals 0. Well, that's never true. So never true means no solution. So if you see something like that, that's a definite no solution. All right, last example. So we can use matrix to help us solve some system of equation problems quickly. So for example, it says figure out ABC of this parabola so that these 3 points are on this graph. How do we do that? Well, this is easy if you kind of remember algebra 2. We kind of solved this kind of problem before. If you have 3 points, each point is always xy. So then when you put in x, you get a y. So that means if you put an x in here, then you get the y here. And that means when you have that point -1, 5, it just means when x is -1, y is 5. And then you can do that with all of the uh, every one of those 3 points. So the second one would be -1 equals to a times 2 squared plus b times 2 plus c. And then the third one is 13 equals a times 3 squared plus b times 3 plus c. And so if you were to simplify this, you get 5 equals a minus b plus c. The second one is -1 equals 4a plus 2b plus c. The third one is 13 equals 9a plus 3a plus c. And you see how this is basically a setup for a matrix problem, right? If you were to solve this by hand, that would be pretty tedious. But if you just want to solve ABC, you can use matrix, right? You can use reduced row echelon form, or you can use inverse matrix. All right, so go ahead and pause the video, use your calculator, whichever way you want, solve this, and then figure out the equation for this parabola. All right, did you get this equation? So this is the equation to this parabola.